Yes, so in the last portion, we discussed about the Vesper theory. And Vesper theory, I told you, we can find out the shape, we can find out the geometry. So if I say XZFO, can you see the board, Vishnu?
Yeah, I can.
So if you see the XZF4, so XZF4, you know it, XZ has a how many lone pair? Because XZ, because XZ is a noble gas. So as
Ye-
it is a noble gas, it has a total 8 electrons, right?
Yeah.
And fluorine are coming. Fluorine need only one electron. So one fluorine, taken the 1 electron each. This
Mm-hmm.
fluorine also, this fluorine also. So they have taken one electron. One is lone pair, other is this lone pair, right? So
Mm-hmm.
lone pair, there are two lone pair actually. But when we are discussing about the when we are discussing about the shape, so you will call it as a square planar. So this
Mm-hmm.
shape is square planar shape. Okay, so it's a
Mm-hmm.
square planar shape. Simple. Okay, now we are coming to the next theory, which is very important, which is called moth. Moth means molecular orbital theory. Molecular orbital theory. And this theory is actually telling us about what? Suppose, Vishnu, you have a one wave. I mean, suppose this is the orbital right now. You before the interference, I want to tell you something. Vishnu, suppose this is the one orbital and this is the second orbital. Okay. So when these two orbitals are overlapping, na, so when this one and this one overlap, so this type of bonding, it is known as a sigma bonding. Sigma bonding. Okay. So sigma
Mm-hmm.
bonding means when there is a end-to-end overlapping. End to end. So whenever there is a end-to-end overlapping, which is quite strong, so it is called sigma bonding. So suppose actually this is d orbital like this.
Yeah.
So now this one, spotlight, yes. Can you just see this one and this one?
Yeah.
So
Mm-hmm.
they also want to overlap. So when they
Mm-hmm.
also want to overlap with each other, so obviously before overlapping of this one, they can't just overlap. If they want to overlap with each other, so obviously this has to be overlap fully. Then only
Mm-hmm.
they come closer like
Yeah.
this, like this. So if they want to overlap now, so they have to come very much closer to each other. So
Mm-hmm.
now can you just see they are completely overlap and now they will overlap. Okay. So this
Yeah.
type of overlapping, which is taking place after the sigma, it is called pi bonding. Pi. And so
Mm-hmm.
can we say this is end-to-end overlapping? No, this is not over end-to-end overlapping. This is sideways overlapping. And sideways overlapping, like just side. First thing is you are just meeting with a guy. Hello, how are you? Okay, like this. So this is end-to-end overlapping. But suppose you are just meeting this thing only. So this is sideways overlapping.
Mm-hmm. Got it.
So which one is strong? What do you think?
End to end.
Yes, end-to-end is stronger bond, but this is not so stronger. This is, you can say, kind of weaker bond.
What's pi bonding then?
Pi bonding means when there is a sideways overlapping of the orbital.
Then
So
what's O
once
bonding?
what?
O bonding, the delta bonding? I don't know what that letter is.
Yeah. I'm going to tell you. Suppose
All right.
whenever there is a single bond, whenever there is a single bond, Okay.
Mm-hmm.
So it has only the sigma bond, one sigma bond, one
Mm-hmm.
single bond. So it means it has one sigma bond.
Yeah. Oh,
If
sigma.
I say there is a one double bond, if there is a one double bond, so its simple meaning is it has one sigma and one pi bond. So
Hmm.
if this double bond contains the one sigma bond and one pi bond, okay, and if there is a triple bond, one triple bond, so in the triple bond, remember always it contains one sigma and two pi.
Yeah.
Remember that. So
Mm-hmm.
how molecules is actually make all these type of bond. Do you know methane, Vishnu?
Mm-hmm. CH4.
Yes. So carbon, if I talk about the carbon, so this is the carbon orbital like this. Okay. So this is the orbital of carbon p. So four hydrogen are coming, and you know it when like the main structure is like this, na methane, CH4. Now, if I draw the orbital structure of that, so you will see, like hydrogen has only s, na, or for the s orbital we have the spherical orbital like this. So
Mm-hmm.
s are coming like this. S are coming like this. Okay. So it
Mm-hmm.
means it is the end-to-end overlapping or sideways overlapping. What do you think?
End to end.
Yes, it is end-to-end. It is not the sideways. Okay. So it means these are the s orbital of hydrogen, which you can see above. And this is the p orbital of carbon because carbon have the p orbital. You know, na, carbon has atomic number 6. So
Mm-hmm.
1s2, 2s2, 2p, what?
Two.
2p2. So we always consider the last orbital, na? I mean last
Mm-hmm.
subshell. So that's why this is the shape. So how many end-to-end overlapping you can see? How many end-to-end overlapping? How many end-to-end overlapping you can see right now?
Uh, there's four.
4. So it means it has a 4 sigma bond only. 4
Mm-hmm.
sigma bond and there is no pi, 0 pi because there is no, you got it, I guess.
Yeah, there's no bonding in between the domains.
There is no sideways overlapping.
Yeah.
Now, if I say, suppose, do you know ethane?
Yeah.
C2H6. So C2H6, there is a two carbon are there. Okay, firstly, I just want to make the shape of like which you have already studied like this. So see, when you make a structure like this, C2H6 like this. Okay, so this is C2H6. It is known as a ethane.
Mm-hmm.
Ethane. So now, if you see that, so carbon, if I draw the carbon orbitals, so one card, see this carbon is attaching with this carbon, right? So it means
Mm-hmm.
one orbital of carbon is definitely making the overlapping with the other carbon.
Mm-hmm.
This carbon is making bond with this carbon, so it is obvious one this orbital is overlapping with this other orbital of the carbon. Very right.
Mm-hmm.
Okay,
Yeah.
and at the rest of the position, which is coming, obviously hydrogen, and hydrogen have the s orbital. So
Yep.
hydrogen is coming like this.
Mm-hmm.
So did you understand?
Yeah, I understand. I'm good.
So this is like bond structure, and this is orbital structure. So can
Mm-hmm.
you tell me, is there any pi bond here?
No. Oh no. Yes, there is.
There is. Oh, okay. Where is it?
There's one.
No, there is no one. It is only the end-to-end overlapping, nothing else.
It's sideways bond, no?
No, there is no sideways. Sideways would happen if I take this. Mr. Computer, spot the, yeah, spotlight is there. If this orbital is making overlapping with this orbital, then it would be pi. But it is not happening. One orbital is direct overlapping with this. Direct overlapping. So if there is a direct overlapping with this, so it is called the end-to-end overlapping. Okay, got it?
So pi bond only happens when when
Because
s orbital
see,
overlaps.
can you see any double bond here?
No.
So
Oh, right,
I already
yeah.
told you now. If there is a single bond, then you will have only pi. When there is a double bond, then you have the pi. Got it?
Got
Okay,
it, yeah.
let's take one pi one. Okay, suppose if I say ethene.
How would ring structures like benzene look like?
1 second, just 1 second.
Mm-hmm.
Let me clear that. C2H4 is there. So C2H4 is there. It means it has a one double bond and it has a four single bond. Am I right?
Mm-hmm.
Okay. So in this, you can simply say, like we will make the same structure as we made before. Yes, Vishnu. Just tell me how many hydrogen it has. How many hydrogen carbon has one single carbon? One
Two.
single carbon has how many hydrogen?
Two.
Two. So it means only two hydrogen will come here because it
Mm-hmm.
need only two hydrogen. This carbon also has two hydrogen. Fine.
Mm-hmm.
But still, like there is only three overlapping. But this one carbon has only three overlapping, but there must be four overlapping because carbon make bond four and there are only three overlapping. Then what will happen? Then this orbital will try to make a bond, try to make overlapping with this. So it will shift it
Mm-hmm.
like this.
Yeah.
So now four overlapping is done. 1, 2, 3, and 4. And same thing for that one. 1, 2, 3, and this is 4. Right? So all are happy. So, but this type of overlapping is called the end-to-end overlapping or the sideways overlapping.
It's sideways because it has
Yeah.
a
And if it is a sideways,
pi
so you
bond.
will call it as a pi or sigma.
Pi
Are
and
you
sigma.
sure? Yes. So can you just count it? How many sigma are there and how many pi are there? Can you count it?
Mm, one pi bond.
Hmm.
Uh, three sigma bonds, I think.
3 sigma. Acha?
Two sigma.
Okay. See, Vishnu, one end-to-end overlapping. Can you see the spotlight?
Yeah.
This is one end-to-end overlapping. This is
Mm-hmm.
also end-to-end overlapping. This is also end-to-end overlapping. This is also end-to-end overlapping. And this is also end-to-end overlapping. And this is sideways overlapping. Now tell me how many sigma, how many pi?
Oh, six sigma.
6 sigma.
Mm-hmm.
Are you sure?
Yeah, and then one pi because it's a pair, right?
Okay. Yes, you are thinking, but don't you think, Vishnu, it is a common one? Why are you considering it as a two? It is only one sigma, na? One,
So it's
two,
5 sigma?
three, four, five. Five only, na? You can't count two times this one. It's a
True,
structure,
true.
okay? If you're counting the row, so can you count two times for the one guy? No.
No.
So same thing. So it means it has a 5 sigma and 1 pi. Okay.
Mm-hmm. Yeah.
And if you unable to find out the number according to this structure, then there is a trick. What trick?
Mm-hmm.
This is the trick. Oh, where is it? This one. One single bond contain one sigma, double bond contain one sigma, one pi. So very simple. Just tell me this structure. How many single bond it has?
4.
And how many double bond it has? One.
1.
So for double single bond contain one sigma.
Sigma
So
bond.
four. So it means it has a 4 sigma. And double bond
Mm-hmm.
contain one sigma and one pi. So total it will become how much? 5
Oh, 5
sigma
sigma, 1
and
pi.
one pi. So it is your choice. Like by what structure you want to find out. Okay.
I like the left hand version better.
Yeah. Anything would be fine. Okay. Got it?
Yeah.
This is how we usually depict the number of sigma and the number of pi. You should know it.
Mm-hmm.
We are coming to the molecular orbital theory. So I want to tell you whenever any molecule is getting formed, whenever you see any molecule is getting formed, so you should know one thing. This is one wave, and this is also the another wave. So if these two waves are going to combine, they are going to overlap. So they are going to make something like this, because this portion this portion is going to overlap with this, so obviously it will become larger.
Mm-hmm.
And this portion is going to overlap with this one, so this is also going to become larger. This is called the superposition. Superposition means that plus side and that plus side become more plus, that negative side is going to add and it become more negative. So this is called the constructive interference, because they are supporting each other. Positive side are getting attracted. Constructive
Mm-hmm.
interference. Suppose if I say, if there is a wave like this, and suppose if there is a wave like this. So if there is a one wave, if there is another wave, see, this is positive, this is negative. So when this positive is going to overlap with this negative, then what will happen? Nothing will happen. This negative, this positive is going to overlap, then what will happen? Nothing will happen. And you will not get anything. Why? Because positive 5, negative 5 cancel. Negative 5, positive 5 get cancelled. So what will you get? So you will get nothing. Okay.
Mm-hmm. Yeah.
So you are not getting anything. So this is known as a destructive interference.
Do the charges just cancel out?
What?
Do the charges just cancel out?
Actually, your voice is not so audible. What did you just say?
Do the charges just cancel out?
Yeah. Exactly. It is just canceling out. Okay. So if you have actually it is canceling out, or you can say if something is positive, something is negative. So you will not get anything. Now, if
Neutralize.
I say I have given you 5 plus 5, and then I am giving you minus 5, then what you have? Nothing. Okay. So
Mm-hmm.
destructive interference. Remember always, whenever I'm saying constructive interference, so you will call it as a bonding orbital. Sorry. If
Mm-hmm.
I say this is called the bonding orbital, And whenever I say destructive interference, I will call it as a anti-bonding. Anti-bonding. So what is this actually? Whenever any molecule is getting formed, or when you are forming any molecule, so actually molecule have both the things. Okay. So Vishnu, molecules have constructive interference as well, and molecules have the destructive interference as well. So both the type, bonding and anti-bonding, both will be there. Okay. What I'm saying, you will understand by this. Vishnu, if I say there is a one hydrogen, like I am making the structure of hydrogen bond. I mean, you can say hydrogen molecule H2. So one hydrogen I am taking here and one hydrogen I am taking here. So hydrogen has only one S1. And if I talk about this, hydrogen also have only one electron, one S1. So when you draw the structure now, this is 1s, this is also the 1s. So actually, Vishnu, it is divided into, it is a reference point. So actually it is divided into two parts, Vishnu. The lower side, you will call it as a bonding. Actually, it is showing the energy. Bonding has very low energy. Bonding has very low energy. Low energy means it has the stability. Suppose Vishnu, if I'm saying like I'm very polite, I'm very shant, I'm very peaceful. So if I'm very peaceful, so my energy will be high or less? My energy. I will, if I'm very peaceful, so I will move a lot or I will remain calm. Vishnu, are you there or not?